Hello everyone. We're going to go through some trig equations in addition to the ones that we did in class. These are going to be a little bit more complicated. So before we actually get into solving this, which says 2 sine squared x minus 1 equals 0, I want to go backwards a little bit and solve some of these regular algebraic equations first. All right, the first one is going to say 7xy minus y equals 0. This is a two-variable equation, but it is solvable even though we don't have a second equation to go with it. This is not going to be a linear system of equations. We can solve this through factoring. There is a greatest common factor here equaling this variable y. So if we factor out, remember how we factor out a GCF, we put the GCF in front, and then we have a set of parentheses with each term in our original polynomial divided by that GCF. So here the y's are going to cancel out on both top and bottom here. So y times 7x minus 1 is equal to 0. Right? So we factored out the greatest common factor. And this lets us use now what we remember is the zero product rule, which says that if these two factors, y and 7x minus 1, both multiply to equal 0, that means that one of these things has to happen. Either y is equal to 0 or 7x minus 1 is equal to 0. So we can solve and get two answers this way. The first answer is that y is equal to 0. The second answer, we can solve this equation, 7x minus 1, we can add 1 to both sides. We can then divide by 7, end up with 7, x equals 1 over 7. So these are our two answers, right? Y is equal to 0, and x equals 1 over 7. Down here is, I guess you could call it a quadratic equation. Do we need to use the quadratic formula? Not for this, because I guess the middle term, the linear term, the b term is missing. We can instead add 6 to both sides and isolate our variable. We can divide by 5 in order to further isolate our variable. So then a squared is equal to 6 over 5. Now we can take the square root of both sides by using the square root property. Remember, the square root property says the square root of a squared is equal to a. And on the other side of the equal sign, plus or minus the square root of 6 over 5. And this can be simplified a little bit into plus or minus radical 6 over radical 5, which then can be rationalized, but I'm not going to bother that. We can leave this as our answer, right? The main thing here is the plus or minus, which is the most often forgotten piece. But we have solved this by using the square root property, right? By not factoring, not difference of perfect squares, because neither of these are perfect squares. We use the square root property in order to solve this quadratic equation. So now let's jump to the trig equations, and we'll see, hopefully, how those first two examples helped. Number 3 over here says 2 sine squared x minus 1 is equal to 0. Right? Sine squared x is the same thing as the sine of x raised to the second power, right? So this entire function is raised to the second power, right? This entire entity, as we might call it. So what I'm going to do here is called a substitution, right? I am going to substitute the letter u in place of the sine of x. And that means our equation is not going to read 2 sine squared x minus 1 equals 0. It's going to read 2u squared minus 1 is equal to 0. So hopefully you can see a parallel between number 3 here and number 2 that we did, which is kind of a similar looking problem, right? We can solve it the same way, first by isolating, doing what we need to in order to isolate our variable. 2u squared equals 1 after we add 1 to both sides. Divide by 2. And that means u squared is equal to 1 over 2. We can take the square root of both sides and end up with u equals plus or minus the square root of 1 over 2. Now this can be cleaned up just a bit. Plus or minus radical 1 over radical 2. Since the square root of 1 is equal to 1 itself, we have 1 over radical 2 as our final answer for this variable u. Now be careful because we're not done. All we did so far was solve for this equation, which we were not asked to do. We were asked to solve for this equation. So since we substituted the sign of x with the letter u, and we got that, I'll write it down here, u is equal to plus or minus, oh, that's a big radical, 1 over radical 2. That means we can do another round of we can back substitute. Substitute our trig function back in here. The sign of x is equal to plus or minus 1 over radical 2. Which means that we have the sign of x equaling a positive 1 over radical 2, and we have the sign of x equaling negative 1 over radical 2, right? That's where these two answers come into play. So let's focus on this one first over here. If the sign of x equals 1 over radical 2, that means the inverse sign of 1 over radical 2 is equal to x. So we can use our calculator or we can use our knowledge. That means x1, our first answer, is going to equal 45 degrees. If you type this into your calculator, you will get this answer of 45 degrees. But remember, with the sine function, two answers are produced in between a range of 0 and 360 degrees. There are two answers that are produced from this inverse sine function, and that means our second answer comes from 180 minus 45. Again, this is because we're using the inverse sine function. And that means this is going to equal 135 degrees, right? One answer here, 45 degrees. A second answer here, 135 degrees. Now, based upon our other answer for u, or the sign of x, we got negative 1 over radical 2. This means that we have to again use the inverse sine function, this time putting in a negative 1 over radical 2 in its place. And this will produce our third answer. I will call it x3. And this becomes negative 45. Now we want our answers to be between 0 and 360 degrees, at least to start. Since negative 45 is too low, it's below 0, what we're going to do here is add 360 to this, right? To find a coterminal angle that is equivalent to negative 45. And that is going to be 315 degrees. x4, which is our fourth answer, our second answer coming from here, but our fourth answer overall, 180 minus our first answer of negative 45 degrees is going to equal 225 degrees. So these are our four answers in degrees. That's 45 degrees, 135 degrees, 315 degrees, and 225 degrees. Now, if your directions are to answer in radians from 0 to 2 pi, then we're going to have to convert all of these answers into radians. So x1, our first answer, was equal to 45 degrees. And we're going to use a conversion rate of pi over 180 to multiply. We can reduce by a factor of 45. And we're going to get 1 and 4 over here. So we're going to have an answer of pi over 4 radians. x2 is going to take 135 multiplying by pi over 180. Once again, these two numbers can be reduced by a factor of 45. 135 divided by 45 is equal to 3. 180 divided by 45 is equal to 4. So we're going to get a radian measure 3 pi over 4, that's equivalent to 135 degrees. Jumping down to our third answer, that answer was equal to negative 45 degrees, or 315 degrees, the coterminal between 0 and 360. And again, we can reduce by 45. That's going to put a 3 up top. No, that's going to be a 5 up top. (315) divided by 45 is equal to 7. That's going to put a 7 up top, and then 180 divided by 4 is equal to 4, and that's what goes on bottom. So 7 times pi, the numerators, and then 1 times 4 is 4, so we're going to get 7 pi over 4. And we have one more answer, x4, which was a measure of 225 degrees. Is that correct? 225 degrees? Yes, it was. Just to confirm that that was correct, we multiply times pi over 180. Divide by 45. 225 divided by 45 is equal to 5. 180 divided by 45 is equal to 4. So 5 pi over 4. So again, our same measures in degrees converted into radians. 4 answers here. So number 4 says 2 cosine x tangent x minus tangent x equals 0. Right? We are seeing 2 separate trig functions here. And we saw something similar to this back on number 1, where we saw an equation that had 2 separate variables, x and y in this case. So let's use our knowledge of solving number 1 to help us solve all the way over to number 4. And I'm going to use a substitution here. You can't use x because it's already being taken. So let's use a and b. A is going to equal the cosine of x, and b is going to equal the tangent of x. So let's rewrite this equation using a and b instead of cosine and tangent. That's going to read as 2ab minus b is equal to 0. Right? Much simpler looking, much more manageable looking. Greatest common factor we can recognize with the letter b. So that's going to be b times 2ab minus b, our original expression over here, this time divided by this greatest common factor. And that's equal to 0 because this is an equation set equal to 0. So b is equal to 2a minus 1. So, sorry, not b is equal to. b times 2a minus 1 is going to equal 0. And if we take this all the way out, we can use the 0 product rule once again. If b times 2a minus 1 is equal to 0, that means b must equal 0. Or 2a minus 1 must equal 0. Add 1 to both sides, and 2a is equal to 1. Divide by 2, and that means a is equal to 1/2. So if b is equal to 0, what does that mean for this, where b is equal to the tangent of x? Well, that means that the tangent of x must equal 0. If a is equal to 1/2, what does that mean for the cosine of x? That means the cosine of x is equal to 1/2. So we substituted a and b for cosine and tangent just to make solving this part easier. Because what we're doing here is strictly algebra. Greatest common factor, 0 product rule, and then solving a 2-step equation, and over here we just got our answer outright. But remember, we're not solving for A and B as our final. We're solving for x, which means we have to substitute tangent of x back in and the cosine of x back in also. Let's look at the tangent of x. If the tangent of x is equal to 0, that means the inverse tangent of 0 is equal to x. So our x1 answer is going to equal 0 degrees. Since we are looking at the tangent function, we're going to get our second answer by taking 180 plus our first answer. So our second answer here is equal to 180. So here's our first two answers, 0 and 180. Let's move this up a little bit so we can get some space. Cosine of x equals 1 over 2 means the inverse cosine of 1 over 2 is going to be our new x, which I will call x3. We can put this into a calculator. We can also use our knowledge of SOHCAHTOA and reverse it to get 60 degrees as our answer for x3. No need to adjust it. It's already positive. It's already within 0 to 360 degree range. So this is our x3 answer, 60 degrees. But because we are using now the cosine function to get this answer, that means we have to use 360 minus 60 to equal 300. And this is our fourth answer. So we have seen all three methods here of solving for our second answer depending on the trig function that comes up. Remember the sine function, we used 180 minus our first answer. For the tangent function, we use 180 plus our first answer. And for the cosine function, 360 minus our first answer. So let's turn all of these into radians. x1 was equal to 0 degrees. Multiply it by pi over 180, and this is the simplest case because 0 degrees is equal to 0 radians. 180 times pi over 180 is also fairly simple because the 180s can cancel out. We're left with 1s on top and bottom, and that means 180 degrees is equivalent to pi radians. So let's take x3, which is our third answer, 60 degrees, and convert this into radians. We can divide by a factor of 60 to get 1 on top and 3 on bottom. So this is going to be equivalent to pi over 3 radians. Our last answer is equal to x4, which turned out to be 300 degrees. Multiply by pi over 180, and we can again reduce by a factor of 60 on these two numbers here. 5 up top, 3 on bottom, which becomes 5 pi over 3. So these are our four answers now. Pi, so 0, pi, pi over 3, and 5 pi over 3. Thank you for watching, and I hope this helped.